Gamebryo has fairly typical Windows installers. First, agree to the Gamebryo license. Then, enter your time lock key. Next, you'll choose what directory to install Gamebryo into. By default, Emergent, Gamebryo 2.5 eval, and which components you want to install. If you have 3D Studio Max or Maya, those should be installed before you install Gamebryo to get the plugins registered correctly. You'll also want Visual Studio or some other C++ compiler for developing code, but that doesn't have to be installed first. You may use PhysX for physics. You'll be notified several times during the installation if it's not installed or if you have the wrong version, but it doesn't have to be installed first either. Once you get through the install process, which may take 10 to 15 minutes, Gamebryo will be ready to go, and by default will open the help file so that you can start reading about how to use Gamebryo. By default, academic and evaluation versions of Gamebryo are installed to see Emergent, Gamebryo 2.5 Evaluation. Inside, you'll find a number of folders. Application Frameworks has source code for a thin, platform-independent Gamebryo program, NI application, as well as a slightly richer version we use for our demos, NI sample. There are also a number of utility libraries, including terrain and the entity system. The build directory has Visual Studio solution files for all of Gamebryo. Documentation directory has full documentation for the Gamebryo SDK and tools. You can also get to this through the Start Programs menu, Emergent, Gamebryo 2.5 Evaluation, Gamebryo 2.5 Evaluation Help. The Samples directory has all sorts of examples to get you started using Gamebryo. Code samples for the engine are split into three places: tutorials, with a single incremental example built up over 9 separate steps; demos, small pieces of code that demonstrate individual engine features or engine subsystems; and full demos, which pull all of the pieces of Gamebryo together to make one application with a large amount of gameplay. We will be working on one of these, Mout, in future parts of this tutorial. There are also a number of art examples, plugin examples, and other sorts of demos here. Most of these demos that have code also have all the original art assets. For instance, Mout has an art files folder, which has raw 3ds Max or raw 3ds Maya files, as well as a data folder, which has those art assets as exported from the tools into NIFs. Going back up, we have the SDK directory, which contains libraries, shaders, and header files for building Gamebryo-based applications on all the platforms you're evaluating Gamebryo for. Third-party code contains other projects that we use to build Gamebryo. And tools contains the source code for the tool pipeline. Animation tool, asset viewer, and scene designer are going to be used by the artists and designers on your project. Developer tools has a few miscellaneous tools like the font creator and other small tools sometimes used by developers that are further discussed in the documentation.
Hello, my name is Paul McLaurin. I'm an engineer at Emergent Game Technologies, and in this series of videos I'm going to talk about the Gamebryo Scene Designer tool. In this segment I'm going to give a general overview of the Scene Designer tool and talk about where it fits into the game development pipeline. So digital content creation tools such as 3ds Max and Maya are great for creating content, such as this character right here. And Scene Designer does not attempt to replace 3ds Max and Maya for that purpose. Instead, Scene Designer acts like a level editor for Gamebryo, allowing you to place items and entities into the scene to build up a larger scene using content that was exported out from 3ds Max, Maya, or XSI. So as you can see on here, each of these is a separate item that was exported out as a NIF file, and we can use Scene Designer to place these in the scene. It also allows you to add and edit properties on various entities in the scene, and these could serve a purpose such as the transformation, translation, and world space of the item, of the entity, or it could be just general data that's useful only for your game. It also allows you to place lights and cameras, so you'll see there's many different types of lights that can be placed in there. Changing those lights gives you an accurate real-time preview of how things change in the game, including shadows, shaders, lighting, and particle systems. Everything you would expect to see in running in Gamebryo, you get an accurate preview of in Scene Designer. Finally, Scene Designer is a plugin-based tool, so all of the functionality that you see, the toolbars up here, all of these different windows and panels, even the rendering modes that show up in here, are all provided via plugins, and this allows Emergent to extend the tool in the future or users to extend the tool to fit very game-specific needs. Scene Designer is installed with the main Gamebryo installer, and it automatically associates itself with GSA files. So simply clicking on a GSA file will open that file in Scene Designer. Each GSA file represents a scene, a single scene that can be loaded into Scene Designer. In this segment, I'm going to introduce you to some Scene Designer terminology while we take a tour around the tool. So this is what the tool looks like, Scene Designer looks like when you launch it first. Each of these panels over here can be docked and rearranged, and these are called command panels in Scene Designer parlance. And command panels are provided via plugins. All of the docking for these command panels is handled by Scene Designer. So it's very similar to a Visual Studio style docking scheme where you have panels that can be auto hidden or docked. You can drag panels into tabs like here and move them around. And whatever configuration you come up with here is actually saved out automatically by the tool whenever it quits. So if you ever need to reset your windows to the default, you can do that by going to the View menu and coming down and saying Reset Window Layout. And this will say, it'll ask you if you want to reset the layout. If you say yes, then the next time you launch Scene Designer, it will be back to the default window layout that the tool ships with. So if you ever get into a bad situation where you don't like your docking format and you want to go back, you can do that way. So I'm going to quickly run through each of these command panels and what they do. So first, let me go ahead and load up a scene so we have something to look at here. This panel's an important panel. This is the selection panel. So the current selection in the scene is controlled on this panel. So as I click in the scene and pick on items, let me make this bigger. I click in here and pick on items and select different things in the scene. The current selection is highlighted over here. I could also select all, select none, or invert selection with this panel as well. And as you just saw, I can multi-select as well, and that's how I can select multiple items in the scene. There's also a concept here called a selection set. In a later tutorial, we'll go into more about this. So the selection panel allows you to select items. This is the palettes panel in which you can drill through the various palettes that have been loaded. A palette is basically a collection of entity templates that can be instanced into the scene, and they can be categorized here as you can see, and then you can double click and instance these into the scene, which will be covered a little bit later as well. This is the entity properties panel, so for whichever entity is selected, you'll get a set of properties in here. The properties will list various information about the entity and are organized into components that can be collapsed. We'll go much more into detail about this in a later segment. This main panel, which is the only panel that can't be docked, is the viewports panel. And this contains either a single large viewport, or if you hit the toggle viewports button, for smaller viewports. Each viewport you can change the perspective and the camera and everything in it, as well as the rendering mode to change from wireframe to standard rendering. And we'll talk more about that in a later section. Over here on these panels, we have an undo panel which shows all of the events, all of the commands that you've done since starting the tool, and you can undo. And if you want to undo multiple commands, you can just click down there and it'll undo multiple ones. You can switch to redo and redo everything as well. And the undo stack is kept from the beginning of the application, and so you always can undo most things that you do in the tool. There's a viewport settings panel which really just shows, let me unhide this so it doesn't pop like this. There's a viewport settings panel where you can choose the viewport camera to use and the rendering mode to use in each viewport, the selected viewport, which is the one that's highlighted in yellow. All of these are available by right-clicking the name in the upper left of the viewport. You have access to all of that same information, but it's here for you as well if you prefer to use this. There's also a components panel. This lists all the components that the tool knows about and allows you to create new components. We'll go into that more later. And then there's a selection sets panel, which allows you to create and select sets of objects. We'll talk about that. Finally, there's a messages panel down here at the bottom, which prints out errors or other messages that may occur during the tool. So if you try to do something and apparently nothing happens or it doesn't do what you're expecting it to do, check the messages panel to make sure that no error messages have been spit out that tell you about what happened or what went wrong. There's a couple other panels here as well, two of which have to do with terrain. So this is the terrain panel. Let me pop this out so it's more easily visible. And this will be talked about in an entirely different tutorial set. And by the way, double-clicking on the title of a panel will pop it out, or as a floating panel, or put it back where it originally was. There's also a panel that has to do with terrain, which is a material palette panel. That's talked about in a different tutorial track as well. And the final one is a template properties panel, which is very similar to the entity properties panel, but gives you properties for the currently selected entity template. So I've talked about a few of these things when I was running through the panels. Let me define a little bit more what I'm talking about. So I mentioned that a palette is a collection of entities which exists in a file on disk in a particular directory, a palette directory. And you can drill through the categories and select palettes here. You can add palettes to it, add templates to the palette. You can create new palettes and delete them all in this palettes panel. An entity template is what's stored in a palette, and this, if you right click and say properties, you can see the default properties that are on this template, and each template can be instanced into the scene to become an entity. So here I've selected an entity in the scene, and you can see that the entity properties panel then shows the properties for that instance of a particular template. If you ever want to know which template an entity comes from, you just go to the selection panel, right click and say show template, and it'll select that template in the palettes view, as well as pop up the template properties for that so that you can see what they are. Also, there is a property. Well, I didn't define property. Property is basically just a bunch of data that is sitting on an entity. And that data really could mean anything. And the properties are grouped into components. And a component is a set of properties and optionally some runtime behavior that gets executed. So for example, a light component, if I select a light here, contains a bunch of properties that define the characteristics of that particular light. That's it for this segment. In the next segment, we'll talk about some of the basics of navigating in the viewport. In this segment, I'm going to talk about viewport navigation in Scene Designer. So here I've loaded up the ruins sample scene, and I'm going to walk through the various ways that you can move the camera around. So first off, the left click in the viewport is the selection. So you'll notice as I click on things, they get highlighted because they're selected. There are certain items that can't be selected, such as the sky view, which is listed as frozen. We'll talk about that in the selection segment. So that's what the left button does. The middle button, the scroll wheel, will scroll you in and out, and it's sensitive to what the center of the screen is on, so it'll scroll faster or slower depending on how close you are to something. The right mouse button will look around, so it's sort of a free look control. And now the scroll wheel and the right click free look, as well as middle click, which is a pan operation, those are true in every interaction mode. So no matter which interaction mode you have active, any of the look interaction modes or even the translate interaction modes, those will apply. So now you can also hold down the middle button and the right button together to do an orbit. This will orbit around whatever the center in front of you is, or if you have a selected entity, it'll orbit around that selected entity. Okay? Any of these commands that you do with the mouse can also be done with toolbar buttons up here. So if you enter in here, you're in pan mode, and then in this case, the left mouse button will pan us around. If we're in zoom mode, the left mouse button will zoom us in and out. If we're in look mode, the left mouse button will do free look around, and in orbit mode, we will orbit. These are, as I said, so I could be in pan mode here, and if I use the right mouse button, I can still do a free look around. So same with the middle mouse button, will still pan me. So all that really is, all this mode up here is changing what the left mouse button does. And if we click back here on select mode, then we can select things again. Your viewports can be maximized like you see it right now, or if you hit the toggle viewports button, we'll shoot down into 4 other viewports. Each of these viewports, you have total control over which camera is being used. So you have a set of standard cameras in every viewport, perspective camera, which right now is really close into the scene. Let me change the rendering mode as well so it's a little easier to see. So right now we're in unshaded wireframe mode, which is the default for all orthographic views. You can change that to shaded wireframe mode if you want and get the lighting information in there. Or you can switch to standard rendering mode, just like anything else. And we're in a perspective camera. We can switch to a sort of top-down view, or side view rather. We can switch to another side view or a top-down view right here. And it remembers the position of the last camera you were in. So if I switch back to perspective, that's where I last was. If I switch back to the top-down view, that's where I last was. And the rendering modes are provided via plugins, and there's several of them in here. So if we want to, get some performance, we can turn shadows off. We can do things like edged faces on the or a no textures mode as well, or even a no backface culling mode. So there's many options there. If you go to the viewport settings panel, all of these options can be controlled via here as well for the active viewport. The active viewport is the one with the yellow highlight, and the easiest way to select a viewport is simply to right-click in it like I'm doing right now. And then you can, whichever the active viewport is, you can go in here and change all these parameters that you can also do with the right-click menu via that same method. And that's pretty much it for navigating around the viewports. In this segment, I'm going to talk about selecting and the various ways you can select entities in Scene Designer. So the first most obvious way is make sure that you're in the select interaction mode and just click on the item. So this will pick into the scene and find the thing that got picked, the entity, and that gets selected. The entity shows up here, and if we bring up the selection panel will show the object that we selected. Now you may want to select multiple things, so I may want to select this. If I hold down the control key while I'm clicking, I will select a second one. And if we look over here, you'll notice that they're actually both selected in the selection panel. That, of course, is another way to select things, is by clicking on them in the selection panel itself. And this is a multi-select list box here, so you can hold down control and select multiple other ones, and this will select additional entities in the scene. You can also click the Select All button to select every entity in the scene, select None to remove all the selection, or Invert Selection to invert what is selected. Now if I have something selected, such as this room right here, I can also click on the Hide Entities button on the selection panel to hide that particular entity. It is no longer listed in the selection list, and I can no longer select it. Similarly, I can select an item such as this cemetery. Let me zoom out a little bit so you can see what I'm looking at. So I can select this and tell it to freeze entities, which will leave it visible but remove it from the list and prevent me from being able to click on it to select it. Now there's filter modes in here. You can either click this button to move to the next filter mode, or you can click the drop down and switch to a filter mode. Now the first time you do this, you'll get a little warning telling you that, hey, the objects listed in this filter, when you select them in the view, the list view here, They don't actually select in the scene because they're hidden. But what you can do is this will show you all of the hidden objects, and you can select one of them, either double click it or select the unhide entities, and notice it just unhid right over here. The same thing can be true for the frozen filter. So you'll see in here the sky dome is already frozen and the cemetery is now frozen, so we can unfreeze that and now it is selectable. And then if we click this again, we'll go back to the other list in which things are selected. You can also create a selection set, and the easiest way to do that is to select a bunch of items and then go to the selection set panel over here and say add. Type in a name for your new selection set, and now you have a new selection set that contains those items. So then no matter what is selected, I can go to this drop down here, select the selection set that I just created, and those same entities will be selected. You can also select things through the selection sets panel right here, as well as remove selection sets that you had created. Selection sets are preserved in the GSA scene file, so they are available at runtime if you need to use them. That's it for this section. In this segment, I'm going to talk about how to work with palettes and templates in Scene Designer, in particular how to create templates from external files or from scratch and instance them into the scene. So we're going to start off here. This is Scene Designer as you first launch it. What we're going to do is we're actually going to fire off a new scene, which this gives us a choice to choose where we want our palette folder to be. So you can either stick with the current folder, which happens to be in the holodeck sample palettes directory. You can go with the default folder, which is in the application data palettes directory, or you can choose a custom folder to select your palette directory. All palettes must reside in this single directory that you choose. For now, I'm going to choose the default directory. So you'll notice there is already a palette in here called General. I'm going to create a new palette here by clicking the New Palette toolbar button. And I'm going to give it a name. And that created this palette, and notice it contains no templates. So we can go back out and see. It shows up as bold because the palette has been modified. This means that when I close Scene Designer or save the scene, it will save out this palette file that has been modified. And you can see the little modified moniker up here. This little drop down up here lets you switch between palettes, so I can go all the way back to the All Palettes mode. Or let's say I'm in the General palette and I'm in the Lights category. I can go back down and drill back up. Just shadowing lights. I can drill back up all the various. This is very similar to Windows Explorer. So now that we've got a palette, let's go ahead and create a template. We're going to create a template from scratch first. So we'll say add new entity template. We're going to give it a name. I'm very creative with my names. You can optionally give it a category. Click OK. And I now get a template. So you'll notice over here, it added it into a category name to my category. And it popped up the template properties for that template. So I have to select the template here, and here's the properties. Notice it has no components in it, just has general properties there. We want to add some components to this template to add some properties. So we click the Edit button here, and brings up the Edit Entity Template dialog. And here we can choose from the available components to add to this template. Notice some of them are grayed out. This means that these particular components depend on other transforms already existing on the entity before they can be added. So you'll notice if I add a transformation component, then several of these became selectable. So it's just the scene graph component, which references an if file. So we'll add one of those as well. So we have transformation scene graph. Now notice over here transformation became grayed out. This is because scene graph depends on properties provided by the transformation component. Therefore, we cannot remove the transformation component before removing scene graph. Once we've added all the components that we want, click OK, and you see that the new components are there along with the properties that they provide. Now, right now, these are our default values. Transformation obviously is all defaults, and the if file path is empty. And just for the heck of it, we're going to go ahead and add a file there. So we click on there and it says choose a NIF file. We want to go in here and just choose a random NIF file. Okay, we can close this out, and now we have a new template here. And if we wanted to instance this into the scene, we can double click on it, click and drag to place it, and we now have a skeleton sitting in the scene. This particular model is not animated. This was from a NIF file. Another way, and much easier way, of adding a template that references either a NIF or a KFM file is to click the Add Art Assets as Templates button. This will pop up a dialog that allows you to choose any number of NIF, KFM, or any other files, and it will import any files that it knows about. So in this case, let's import Life Force, which is a particle system. When we click OK, it comes in and we can choose what category we want to put it in. And if you want to browse to the categories, you can do that. Say I'm just going to put it in the root of my palette. Click OK. And I now end up with a Life Force template. If we right click and look at the properties for this, you'll see that it's automatically added a transformation component and a scene graph component that points to the file that we chose. So this is really a shortcut method of importing or creating entity templates, and you can multi-select many NIF files or even non-NIF files. I can multi-select a bunch of files here and say open, and it will go through and only add the ones that make sense, that are NIF files or KFM files that it knows about. So then if we take this new one that we instanced and throw it into the scene, we now have this particle system here, this Life Force particle system, which I'll scale up a little bit so it's more visible. Okay, that is the creation mechanism for creating templates into the palette. Now you saw on the components there that you can choose between, so let's go back to that so I can cover that a little bit more. Let's say I want to add extra data to every Life Force entity that is only usable by my game. So if we come into the Components panel over here, we can see these are all the components that we know about. So you can look at them, see what their different properties are. Or you can click the New Component button down here, give it a name. Let's say Strength. That's actually not a good name. Let's say, well, sure, Strength. We'll go with that. So we add that, and then we can add a property to this, and that property can be called amount of strength. And we want to make that, say, a float property. We can give it a description. Click OK, and you'll notice the property shows up in here. Or we can add a second property here, say direction of strength, and that can be a 0.3, and we're not going to give it a description here. So now this component exists in the Components panel, and we can now choose anything. Let's say the Life Force here. Right-click and say Properties. Go in here and say Edit, and you notice that our new Strength component is available. We add it, click OK, and now we have these properties available in here. And more importantly, we have those properties available when we select the entity in the scene. That pretty much covers creation of entity templates and palettes. One other thing I'll mention is if you want to delete a template, you can do so by right-clicking and saying delete, but it will not let you delete it if an entity in the scene is using it. So you would first need to delete that entity, then you can delete the template. If you don't know which entity in the scene is using it, you can right-click and say Select in Scene, and it will select any of the entities that are based on that. And then you can delete that entity, and then you can delete the template. template. You can also delete a palette directly up here, which is a non-undoable operation. It actually deletes the file off of disk. You say yes, there you go. That's the end of this segment. In this segment, I'm going to talk about how to create a scene in Scene Designer by placing entity templates into the world. So I've got a blank Scene Designer window here. I'm going to maximize the perspective viewport so we can see what we're doing. Go into the MATLAB palette and select a room. And I'm going to select Room Circular Observatory. Double click on it. Enters me into create mode. You'll notice my cursor has a little crosshair. When I'm in create mode, I can left click to place an entity in the world. Now, this is a very big entity. And let me actually zoom extents on it so we get a little bit better view of it. So here's this world, or here's this room that I just placed. And to exit the create mode, I can right click, which is what I just did. And since I'm going to be placing entities in this room, I'm actually going to freeze this room so it doesn't interfere with me selecting other objects. So I'm going to go to the selection panel and click the Freeze Entities button. So now when I click, I can no longer select the room. Now let's place some things into the room. So we're going to go into the props here and choose a table. Let's choose a this one's fine. And we'll double click and place it in there and move it around. And it's placing it right now onto the ground plane, which ordinarily would be fine. But I'm going to cancel my selection right now by right clicking while I had the left button down before it gets placed, and that canceled it. And now I'm actually going to illustrate something. So I'm going to switch over and unfreeze the observatory room. I'm going to translate it downward so it's not on the ground plane anymore. And then refreeze it. Okay, so now we'll go back and we'll place the table again. And notice, we're placing it, but it actually got placed on the ground plane, which is not what we wanted. We wanted it placed on the floor of the room. So to remedy that, I'm going to go ahead and delete this by pressing the delete key. We can go up here and activate the Snap to Surface tool, and then come back down and place this. And this now is snapping to any surface that I am over. So right now I'm on the floor, it snaps it to that. And now I can move my camera angle down, and you'll see that I'm actually snapped to the floor where I want to be, not to the ground plane. This works for other props as well. So let's take a little phonograph prop and place it on top of the table. And notice I'm holding down the left mouse button while I drag it around. And this gives me a little ghost image of what the object will look like. So you notice here it's on the floor, and I move it over to the table, it's now up on the table. So this makes it really easy to place items on top of other items and have them line up correctly. There's even an Align to Surface tool, which you'll see over here. So if I wanted to place another prop, say a set of books and a skull, I can do it. I can do it on the table. I can do it on the wall. I can do it on the side of the table. So what this does is it will align it to whichever surface that you're actually clicking on. So it makes it real easy to place things on walls, for example, or on sloped surfaces without having to manually align them. So we've placed a couple entities into the scene, and that's pretty much it for this tutorial. Was just to show you how to get these things in and place them appropriately. In this segment, I'm going to talk about how to set up grid and snap settings in Scene Designer to more accurately place entities in the scene, especially if your entities are designed to match certain grid and snap measurements. So this is the holodeck scene that ships with Scene Designer, and in it, each one of these hallway pieces is a separate entity that they were all snapped together. And the easiest way to show this off, normally when I translate, it's very smooth. And in order to snap these pieces together, I would need to zoom in really far and try to figure out whether or not it's lined up, and it can be pretty disastrous. But instead, you can set up Scene Designer to snap to a grid. So the first thing you want to do is, based on how you've authored your entities, you want to set up your grid and snap settings appropriately. So if you come in here, I can set up my rotation snap. I've set up here to have a 45-degree increment. My translation snap, I've told it to snap to 100 units. Each one of these is 100 units wide. And the scale snap is set to snap to 0.1, which will actually make that 0.25 while we're in here. You can also set up how many snaps per grid line you have in the grid section in the options. In this case, we want 1 snap per grid line, so you'll see in a moment how that works. So now if I come up to the toolbar and I can turn on Translate Snap, I can turn on Rotate Snap and Scale Snap. And now when I translate, it's actually snapping by units of 100. So right now this object was not aligned. Let me back up until he was to his original position. So now that he's in his original position, you can see that I can easily snap these together by taking this end cap off, moving it over, snapping this over to there, and I've now created a new hallway over here with an end cap. Let's see a little bit better in this view. And we can also, if we want to rotate things as well, we have Rotate Snap, which will snap by 45 degrees. This, as long as you've designed your assets appropriately for this, it can make snapping together worlds, say dungeons for example, very, very easy to do. And here's the scale snap of the 25% scale. And the nice part about turning on these snap settings is that you don't have to worry about manually lining things up. Scene Designer can take care of that for you with the grid. And notice that we're snapping one grid item every time we move an item. So that's pretty much it for the grid and snap settings. For a scene like this, it can be very useful to use the shift cloning technique as well. So if you hold down the shift button while you're translating something, you can clone it. And so that's how this scene was built, was all of these various things were placed in the world and snapped together, and then simply shift cloned to clone different holloway segments and move them to the appropriate location. In this segment, I'm going to talk about properties in Scene Designer and how you use them. So here we have the Mad Lab scene. I'm going to select the mobile, that's entity in the middle here, and its properties show up over here in the Entity Properties panel. Now you'll notice in here that the properties are categorized by component. So we have in this particular entity a scene graph component, which contains a NIF file path, and a transformation component, which contains its translation in space. If we select the spotlight over here, we have different components. Over here we have a light component, which contains a bunch of properties that include the color of the light, the type of the light, and so on. And we contain a shadow generator component, which indicates that this light casts shadows and the different shadow technique that it uses, as well as size hints for the shadow maps and other parameters. So properties in general can be inherited from, they're defined by a template. So if we select this item here and we go over here and say show template, we'll notice this is the prop mobile template. And if we look at this template, we see here are the properties which are defined by the components in that template, if you remember from the components segment. And this specifies a particular NIF file path for this object. Now this NIF file path property is actually inherited. So if we come down here, we'll see that this particular NIF file path property on the entity itself is not bold. That means that it is inherited from the master. We can, so if I were to change the property up here to something else, so let's change it to something completely different, then what we would end up with is a different file that's loaded, and you'll notice that this has changed to inherit from that. Now we can right-click on any property that is inherited and tell it to make it unique. This means that even if we come up here and we change this back to what we want, which was the mobile, it will not affect the value of this property in the entity that inherits from that template. Now we can go in and change it here as well to be something else entirely. There we have a pillar that is rotating. So that's fine. And if we ever want to go back to inheriting from the master, we simply right-click on the property and say Reset, and we go back to inherit that property from the template. So that's the basics of inheriting properties. Some properties, such as these transformation properties, are not inherited. For a transformation component and translation, rotation, and scale, it doesn't make a lot of sense to inherit that from a template because each instance will have its own values. And so these values, notice, show up as bold because they are unique, but you cannot reset them. There are a few other things in the Entity Properties panel that are of note. One is whether or not the entity is hidden or frozen. These can be changed here, but that will cause the entity to be unselected, and you need to unhide them via the selection panel. The name is also listed here, and if we wanted to change the name, we could do so by simply typing in here and pressing Enter. So now, if we look in the selection panel, it's now named My Prop Mobile 01 instead of Prop Mobile 01. I think that is it for properties. Oh no, actually I remembered. So this is a different, each property can have a different type. And this is a string. It's just a file path, but it's also a file path. It's a NIF file path, in fact. And that tells Scene Designer to allow you to click this little ellipsis button and pop up a file choosing dialog. So each property can have a different editor, such as this. So for example, if we come in here for this light, we want to change the color of this light, we can click in here, click down, and select a different color for the light. Same thing for the light type. If we don't want this to be a spotlight and we want it to be a point light, we can click down there and it changes to a point light. So each property has its own data type as well as its own way of editing the property. There's also property collections. This is an example of a collection. So it says affected entities expand to see 4 subproperties. So if we open that up, we can see in here that we have the 4 different affected entities. And this particular property does not allow you to edit the entities in this expansion. Instead, we have to click this little ellipsis button to bring up a different dialog that allows us to add and remove items in the collection. Another example of an expanded property is translation. And in this case, we can actually see the subcomponents X, Y, and Z and can actually go in there and change them if we want. Notice the light has now moved. So that's it for the property basics and how properties work in Scene Designer. Segment, I'm going to talk about settings and options in Scene Designer and how they're saved out. If you click the Options toolbar button, this will bring up the Options dialog box. In this box, there's a bunch of categories, and each category has several settings in there. These comprise things from how long the autosave, how many minutes should go between autosaving, to the color of the grid lines, to the palette directory, to the application that you want to launch externally when F5 is pressed. Any settings or options that are modified in here are either saved out per scene or per user or globally. The plugins in Scene Designers themselves determine how and where these settings get saved out. Many of these options also correspond with toolbar buttons as well. So if we want to come in here and say rotation snap, I want to turn that off because it was on before. I can come in here and then look at rotation snap is now false. And if I set that to be true, this button gets depressed. So many of these options, correspond with things in the scene. There are also options for the tool itself, such as undo settings, whether or not selection commands are undoable or view commands are undoable. By default, selection commands are undoable, but view commands are not. You can also go in here and change the distances for each of the orbits and pan and various other settings. As you select each option, there is a description that appears in the bottom right, and this description will tell you what that option is about, and in some cases whether or not it's saved per scene or per user. That's pretty much it for the options and settings in the tool. Those settings are saved on disk in either a user directory, in your documents and settings user directory, application data, or it's saved out in a separate file along with each scene that you save out called .scene. So in this case it would be ruins01.gsa, and then it would append .scene.settings, and that contains all of the settings that are specified there, as well as other information about this particular instance, such as the viewport configuration that was present for that particular scene. In this segment, I'm going to talk about the samples that ship with Scene Designer and what each of them shows off. I'll also talk about how to preview scenes using the Scene app sample. So first we're going to open up a scene. We'll open up the holodeck sample. These samples, by the way, can be found in the Gamebryo samples models Scene Designer examples directory, as you can see by this path right here. All right, so this is the holodeck sample, and what it is primarily, it's very simple graphically, as you can see. What it's meant to show off are the fact that you can, if you turn the snap on, each of the items, the entities in this scene, was designed to snap very nicely together on a grid. And so this particular scene, or one like it, can be snapped together very, very quickly by putting together all of these different pieces and snapping them onto a grid and adding end caps like this. This also shows off particle systems. There's several particle systems in here and some lighting. So each of the particle systems has a light associated with it, as you can see, that's of different colors, and there's a green light there. And in addition to the lights, there are also several cameras in the scene, so we can switch between. So there's a camera that's sitting here looking at the fire. There's one looking at down the hallway. There's one looking at the mist. There's one looking at the sun, and then there's a player camera. This is actually the starting camera for this scene. So there's a special type of object in here called Scene App Camera Controller, and it has parameters in here such as invert pitch, the max amount of space that the camera can drop while walking around, the speed for walking and running, and the start camera, which happens to be player camera. This data is used when previewing scenes from Scene Designer in the Scene app sample, which is under full demos in samples full demos in Gamebryo. And Scene Designer actually has built in a functionality for automatically launching the current scene and previewing it with Scene app. So you can either do that by choosing View Launch External Application, or by simply pressing the F5 button, which I've done right now. This will launch Scene app and bring it up with your scene using your starting camera, and it allows you to walk around in the scene, and it does terrain following. In this case it's just a flat plane, so there's not much there. It also does can do 2D collision, so notice I'm running into the walls and sliding, and I'll show you how this was done. But this is a very useful sample application for previewing your work. Hit escape to quit out of that. I'll just point out to you, if you bring up your options and go to external application settings, you can actually specify any command line to run as well as the path to any application. This is the command line options. And so if it's blank, it does the default path for Scene app. However, you can specify this to be your game and specify a parameter such as maybe the name of the file, or any additional command line options. The name of the file is automatically passed. And so this allows you to set up any application as your previewing application, not just CNAP. So you saw how we were sliding around in that example, and that is because we were simply picking on the objects that were on the ground here and doing some very simple collision based on them. So now I'm going to open up a different scene. I'm going to open up the ruins scene. The ruins scene is primarily to show off the shadows, the dynamic shadows in Scene Designer. So as you can see right here, each skeleton actually has a shadowing spotlight that's inside of it. Let's get a better view over here of this guy's spotlight. So if we select that spotlight, we can see on here it's got a light shadow generator component, and that shadow generator component tells it the shadow technique that it wants to show, and because it's actually inside the skeleton, it's casting shadows of the skeleton's ribs all throughout the scene. We also have a camera up here that's actually uses an inherited transformation component to inherit its transforms from the skeleton. So if we switch to that camera, you'll notice we can sort of watch the skeleton move around in the scene from an animated viewpoint. Another thing to point out with the shadows is this directional light up here, which is using a PCF shadow technique. We can change the shadow technique that's being used, and you'll notice the quality of the shadows has been significantly reduced. If we switch it up to here, it makes it a lot smoother. And then we can animate this around so you can see that this is actually a dynamic shadow casting light. Let me change my viewpoint a little bit. There. So you can view the shadows happening in real time and being cast in real time in Gamebryo. The final sample that I'm going to open is MADLAB. MADLAB was meant to show a larger area of interconnecting rooms, and these rooms are set up such that they each are their own entities and contain various numbers of props that are all individual entities as well. So we can go in here and see, here's a nice room with this mobile in it. We can zoom down into one of these rooms and see that there's a table. Excuse me. There's a table here with various objects on it, and there's also dynamic shadows being used in this thing as well. So you can see the shadows here on the floor that are coming from lights up in the air here. So if we want to hit F5 to jump into this model in CNAP, this is the default model that actually runs when you run the CNAP application. So if you go to your full demos directory and you launch CNAP, you'll actually see this model loaded up. And you can look around and see this particular model. So that's pretty much it for the samples in Scene Designer, and that's the end of this segment. In this segment, I'm going to talk about lighting in the Scene Designer tool and how to set it up and optimize it. So first off, I'm going to create a simple scene. This is the holodeck palette, and I've got grid and snap settings turned on. I'm going to place a couple hallway sections here. So here's one, and then we'll clone another one right over here. I'm holding down Shift to clone it. And then we'll rotate this back around. There we go. So now we've got a very simple hallway segment. Now notice as I place these two segments, they appear lit and by sort of a flat light. This is because default lights are turned on and enabled by default when in Scene Designer when there are no other lights in the scene. You can change that if you go to your options, light settings, and you toggle use default lights on and off, and you can see the lights turn off. So now we're going to go ahead and add a light to the scene. So I'm going to go up to the general palette, and add a light. Now all these lights templates here are really just standard entity templates that have a transformation and a light component added to it. And all of these templates have the exact same light component added to it, they just have different properties. So for example, this particular one is a directional light, and we're going to go ahead and place a spotlight in the scene here. Actually, I'll place a point light first. We'll place it right there. I'm going to turn grid and snap settings off. So now notice right now that the light has been placed, the default lights are no longer taking effect, but nothing is lit. This is because there's another option in the light settings, which is automatically add entities to lights, and this happened to be false. So if that were true, so let's place the light again, notice the default lights come back when that light's deleted. If that were true when I place this light, you would see the light affect all of the entities. And this, by the way, is the default setting, is for it to be on. So every light that you place will have all of the entities added to in the scene added to its affected entities list over here. That can be useful for small scenes like this where you really only want to light a couple things and you want everything to be lit. However, you don't always want that to happen. So for another case here, let's turn that off. Okay, and now we'll come in here and we'll place a spotlight. Let's place it over in this other corner. Now notice it doesn't light anything yet. We'll go ahead and move it up and we'll rotate it a little bit so it's pointing sort of into the corner. Alright, so now this light is not affecting anything right now, and if we want it to affect things, we can go to the affected entities property, come in here and select the hallway segment that we want it to, select the hallway segment that we want it to affect. So in this case, we selected the segment over here, and you can see the light is now affecting that. Now let's walk through some of the properties that you see with the light here. So the first up are the attenuation properties, and these are constants in the lighting equation that can be modified, and they directly map to the attenuation properties of a Gamebryo light. So you can see here the attenuation property, the quadratic attenuation property of this point light is rather small. If we wanted to change that to something larger, we could, and we would get a very different attenuation. So you can fiddle with those in here on a per light basis, or you could fiddle with them in the templates and create different templates for each of the lights that have different characteristics. Another setting is the actual type of light. As you see down here, this is a spotlight. I can change the type of light simply by clicking there and making it a point light. Or a directional light, in fact, can be done the same way. Now notice, since this light is only affecting this entity, it's only contributing to lighting on that entity, which is why there's that discontinuous spot there. And on this particularly, we can adjust the spotlight cone. So I'll make it a little bit bigger so it's a little bit easier to see right there. So now, right now, if we we can also change the color of the light. So let's go in here and do that. This is another property here. So we'll change this one to be sort of a yellowish color. We'll come over here and change this one to be sort of a greenish hue. So you can see the immediate response of the lighting in here. You can also set the dimmer of the light to control, how bright the light is, and make some adjustments there as well. So let me select the spotlight here and rotate it over, and notice that, as I mentioned before, the yellow light is not affecting this entity over here. It's only affecting the entity on the left. This is because we manually added only that entity to the light. Well, sometimes you want the light to, you want to automatically determine which entities should be affected by a light, and that's easy to do. Simply select the light, come up here to the Optimize Selected Lights button, and mash it, and now both of these entities are in the affected entities property for that light. Similarly, we can rotate this back so it's only pointing at this one entity, hit Optimize Selected Entities again, and that other entity is removed. This can be very useful when you are setting up lighting for a large scene and you only really want lights to affect the entities that they actually have a sphere of influence over. The same thing can be done for point lights based on the attenuation properties and whether or not the majority of the light reaches the other entities. Another thing you can do is you can select an entity in the scene and hit the Select Lights Affecting Entities button, and that will affect both the lights that are affecting that particular entity. So that's an easy way to figure out which lights are affecting which entities, short of searching through every light. So those are the light basics and setting up and optimizing lights in Scene Designer. Segment, we're going to talk about the various components that are available inside Scene Designer. These components can be seen on the Components panel, which I'm unhiding right here. If you select this drop-down, this lists all of the components that are available in Scene Designer. Components can be added by plugins, so you can add additional components that you would like for your own game. Also, components can be created from scratch with the New Component button. Let me cover the default components that are added, that are included. The first one up is an actor component. This allows you to specify a KFM file and a sequence ID and whether or not you want the actor to accumulate transforms. And this is used for all of the animated characters in the scene here. So if we select on one of the skeletons and look at its properties, you'll notice that it has an actor component. Let's zoom in on this one. So he's right here. He has an actor component. It has a KFM path that points to the skeleton's KFM. And if you click the drop down, you can choose a different animation. This particular scene was authored with the walk animation to look correct for this movement of this character. The next component is a camera component. This contains properties for the aspect ratio, the field of view, whether or not the camera is orthographic. If we switch to a camera in the scene, you can look at the properties here and see, right up here. And we'll see these better if we actually switch to use this camera. So here's this camera here, and you can notice that if we change the aspect ratio, the bars on the top and bottom change appropriately, or change the field of view, or turn it into an orthographic camera. The next component is an inherited transformation component. This is very similar to a transformation component, which contains translation, rotation, and scale, except that any combination of those can be inherited. So if we look at this particular camera, which I'll switch to, notice that this camera is following this skeleton as he's walking around. If we look at the inherited transformation component, we notice that the source entity for this object is skeleton. Also, you can specify an attachment point, and this is the node name inside of that entity. So if that entity is referencing a scene graph, the node name for the NI node inside that scene graph that you wish to attach to can be typed in here. You can also say whether or not you want to inherit rotation, translation, and scale. So notice the camera is sort of pitching back and forth. I can just turn inheriting rotation off, and that will allow me to change my rotation, but yet still inherit the rest of the properties. There's also a light component. Light in the scene contains a light component, and this contains things such as the color of the light, the attenuation parameters, and the dimmer switch, how bright the light is. You can also change the type of light. So if you see the light back there is a point light, we can change that to be a directional light or an ambient light or a spotlight. We're going to put it back as a point light so we get all the shadows the way we want. Next is the scene graph component, and really all this is a NIF file path property that points to a particular NIF file. So if we select pretty much any object, any entity in the scene, it has a scene graph property that has a particular NIF file specified. This was a component that is in this scene but was actually created, and you'll notice down here you'll have the add, edit, delete on this property, so we can, or this component, so we can bring this up and edit this particular property. We can add properties to this component. So it's not a standard component that ships with Gamebryo, but this particular component contains properties that are used by the Scene App tool for previewing purposes. The shadow generator component contains lots of parameters about generating shadows with the Gamebryo shadowing system. So if we switch to a light, one of the lights in the scene here, it's actually the directional light that I want, and let's switch to a different camera here. So notice we've selected this directional light, which as we rotate around you'll see has shadows. We're getting a little bit of gimbal lock here. There we go. And we can change with the shadow component, shadow generator component. We can go in here and change the shadow technique that's being used. Switch this to standard. Notice it gets all very blocky down here. For PCF, it's a little bit more smooth, as well as the size of the shadow maps. Get much lower resolution shadow maps, and the unaffected casters and other properties. The terrain component is used when placing terrain in the scene, and has a number of properties that are set directly and can be set via the terrain panel. The terrain sector component is another component that is used for placing terrain. The transformation component is a very basic component, just contains rotation, translation, and scale properties. This is used on pretty much every entity in the scene, and those properties are edited by the translation interaction modes. And there's a water component. This component is also used when placing terrain and contains many of the properties that are used to define what the water will look like. That's an overview of the components in Scene Designer. In this segment, I'm going to talk about cameras in Scene Designer, how to create and place them in the scene, and how to manipulate them via the viewport controls. So right now we have the holodeck scene sitting up here, and there are already several camera entities already in the scene. You can see some of them here: fire camera, hallway camera, player camera. And if we want to switch between them, you can simply right-click on the name of the viewport, go down to Scene Cameras, and you can switch between all of those different cameras. So fire camera, hallway camera. These are just static cameras that were placed somewhere in the scene overlooking points of interest. And then those are all those cameras. Now if we're going to go back to the standard camera, each viewport has a set of standard cameras that are not saved in the scene, such as perspective, user, and then down each of the various axes. So you of course can choose those as well if you want to get orthographic views. The perspective is the only perspective viewport, everything else is orthographic. The Scene Designer remembers the last position of each of the cameras. So here was where the perspective was. Positive X was back out here, so you can switch between different perspectives on the same viewport if you so wish. Now let's go ahead and place a new camera in the scene. We're in the general palette. Go to cameras, and let's look at the properties first of this template. So as you can see here, all a camera really is in Gamebryo, or in Scene Designer, is an entity template that has a camera component added to it. This one also has a transformation component added to it so that it can be placed in the scene. It could potentially have an inherited transformation component attached to it so that you could attach it to some other object, as I'll show you in a moment. The camera component here has various parameters that can be set up for this camera, and so by setting up different templates, you could set up orthographic or perspective cameras with different fields of view, different aspect ratios, and clipping planes. So for now, we're going to throw this into the scene and place it right there. Sort of places in an odd configuration. Now you can either manually rotate the camera just like any other entity, manually transform it. But the easiest way to do it is probably just to switch to that camera. Here it is, camera 1. And then use the standard camera navigation controls to manipulate it. So here I'm using the middle mouse button to pan, the right mouse button to look around, middle and right mouse buttons to orbit. Let me see, middle and right mouse buttons to orbit. We're orbiting around a selected item. That's what's going on there. And the mouse wheel to zoom. So you can set this up and to easily manipulate the camera to the place that you actually want it to be in. So that's sort of the basics of placing cameras in the scene. We can make this camera orthographic or perspective, and with the orthographic we can fiddle with the frustum length to get different effects and different amounts of zoom effectively. So that covers the placement of cameras in the scene and the manipulation of cameras in the viewport. One last thing I wanted to add was to show an inherited camera that's attached to something in the scene. So if we bring up the ruin scene, once it loads up, we will see that there are multiple cameras in the scene, and one of the cameras, as you can see, is moving around the scene. So if we switch to that camera, it's a camera that's following this particular skeleton walking around. So if we go and select this camera, node attached transform, come down here, we notice that it has an inherited transformation component that is pointing at the skeleton, and not only that, but a particular node in the skeleton called node camo1. This is the node in the Gamebryo NIF scene graph that's loaded for the skeleton. So this is a way that you can attach any object, but cameras, lights, various other particle effects, as you see here, to other objects in Scene Designer. Hello, my name is Paul McLaurin, and in this video I'm going to talk about one of the new features that we've added for Gamebryo 2.6 to Scene Designer called Layer Support. Layer Support is a way in which you can have multiple editors on a particular scene all working simultaneously because we've broken out chunks of the scene and to be saved out into separate files or layers. So this is a modified version of Scene App, of MATLAB that ships with Gamebryo 2.6. And as you can see over in the new layers panel, I've broken out each of the rooms here into their own layer. So I can very easily show and hide each of the rooms here to display that which entities are in that layer. So it's very easy for me to turn off layers that I'm not interested in and only edit the layer or layers that pertain to me. You'll notice layers can be read-only on disk. This is often the case in a source control system such as Perforce. So in this case you have a layer that is read-only, the central hub layer, and notice it has the big X icon there. What that means is that I am unable to actually modify any of the entities that are in that layer. So if I were to go in and select this central room here and look at its properties, you'll notice that all of its properties are read-only, and I cannot actually change any of them. This was a change made to Scene Designer to support multiple layers, so any layer that is read-only, all of the entities in it are also read-only and cannot be modified in any way inside the tool. Now, if I want to actually add an entity to a layer, you can set the active layer. So this little hard hat icon here indicates what the active or current layer is. So let's say I wanted to add something to the cemetery. I could set the cemetery as the current layer. Let me zoom down here onto the cemetery, and then go ahead and place some sort of object in the cemetery. We're going to put something very incongruous like a table. So now we've placed a table in the cemetery, and notice that the table is hidden and shown when the cemetery layer is hidden and shown. Alright, so let's delete that and come back up. There are several things you can do with layers. You can also freeze them, so if I want to make sure that I don't accidentally click on something in the central hub, I can do that, and now everything in the central hub will not respond to my clicks, but other things will. So these are convenience methods, and notice I can hide and freeze a read-only layer without any problems. It doesn't actually affect the hidden or frozen state of the entities in that layer. So if I had some entities that are hidden, I can hide that layer and then unhide it, and those entities will still remain hidden. So you don't have it overriding. If you have things hidden by default or on purpose, you won't have things overriding that with the layer system. There's also a default layer. This default layer corresponds to the actual file that is open in Scene Designer. So you still open a main file, in this case madlab.gsa, and it references other layers. That main file always shows up as the default layer and can be read-only as well and can be hidden and shown as well. When you hide a layer that has sublayers like this, it actually hides all of the sublayers. You can always go in and unhide sublayers if you so want. The other thing that you can do is you can also have nested sublayers. So if, say, the cemetery layer also had some other sublayer there, then we would see it displayed in a tree view here with a sublayer as well. So you can open each individual layer on its own as a default layer in Scene Designer and edit that, or you can open a layer that references that layer, as is the case here with the MATLAB. Not every layer needs to contain entities either. You can easily have a layer such as MATLAB. It currently does contain things like the Sky Dome, but we could actually have it just be a totally empty layer that just references other layers, and that may be a good way of setting up your scene. You can delete layers off disk, which actually removes all of the entities in that layer from the scene, and you can optionally delete the file from disk. And this, unfortunately, is a non-undoable operation, so be very careful when you do that and make sure you really do want to do that. You can also just remove a layer from the scene. Let's say I don't want the cemetery to always load every time I load the madlab.gsa, so I can easily come in here and say make implicit. What that does, you'll notice it creates this little group over here called implicit and has cemetery. The reason why it's implicit is because there might be things in the default layer that reference the cemetery. For example, there may be lights or other entities that reference entities in this layer, or there may not be. If I were to save this out and load it back in, if there are any dependencies with the cemetery, it'll be loaded as an implicit layer. If there are not, it will not. When the layer is explicit, if I say make explicit, it makes it explicit in the active layer. Now it will always be loaded with the madlab.gsa layer, no matter whether or not something in the scene actually references it. You can add a new layer from scratch, which prompts you for a file name, which you then fill in. And you can select a bunch of entities. I select several entities and say I want to create a layer from those selected entities. And in this case, actually, I have read-only things referring to it, so I actually can't do that. And what that will do is that will actually move all of the selected entities into that new layer. You can also import a layer from disk. Any GSA file or any scene file at all can be a layer, and you can import it with this button here and just choose a layer off disk. If you import a layer that already exists, it actually will just add it as an explicit layer to the current layer. So if I wanted to have the cemetery actually refer to the torture chamber, I could do that by saying import torture chamber, and now I have cemetery also referring to torture chamber. Now, even though there are two entries in this list, there really is just one layer. As you can see, an operation performed on one is performed on both. And if I don't want this anymore, I just say, hey, make implicit. There it goes, it's gone, but it's still explicit for the madlab.gsa layer. So that's the overview of layers in Gamebryo 2.6. Hello, my name is Paul McLaurin, and in this video I'm going to talk about one of the new features that we've included with Gamebryo 2.6 Scene Designer called prefabs. A prefab is really a collection of entities that can be treated as a single entity, so it can be very useful for building up complex props. So to illustrate this, I'm going to go ahead and, using the MATLAB palette, create a few entities in here. So we'll create a table first, turn on Snap to Surface, place a books prop on that table. Let's pop some cans on that table, and then maybe a phonograph. Alright, so now we've got all of our entities up here on this table, and this is a nice little collection of entities, and let's say I might want to instance this multiple times in my scene as a single entity. So there's two ways to create a prefab. One way is to, if I'm creating a scene from scratch like this, the whole scene's going to be a prefab, is create my scene in a new scene, save it out, and save it out somewhere in the palettes directory. And we can actually put it in a subdirectory as well. So we're going to put this in a subdirectory called test palettes, or test prefabs rather. Type this in here, and we'll call this table with stuff 1. Alright, so now that's saved in the palettes directory. What Scene Designer does when it loads, I'll create a new scene here now, keep the same palette directory, is it loads all the GSA files that are in the palette directory when it loads up, or when you open a file, and all of those GSA files underneath the palette directory become prefabs. So you can see in here there's a new top-level prefabs item in the palettes panel. If I double-click it, you'll see categories in here. So, we have test prefabs directory that I just made. These correspond with the directories on disk. So if we come in here, we see table with stuff 01, or this is the prefab that we just created. Now if I want to instance that into the scene, I can double-click it, which enters create mode, and then just place it somewhere. And then now I've got, I placed all of those entities as if they were a single entity. When I click to select on entities in the scene, I can pick on any part of this entity, and it will select the entire entity. So it really does treat it as a single entity. If I look in the selection panel, there's a single entity listed there called table with stuff 101, and it's surrounded by brackets, which indicates that it's a prefab. So if I click on it, it'll select it. Now one thing I could do is if I want to click on sub-entities here, there's a mode to do that called Pick Prefab Entities. If I turn that on, now when I pick, I'll be selecting the sub-entities in that prefab, not the prefab root. And you can see this over in the selection panel. The table with stuff prefab has actually just expanded out, and we now get all of the entities underneath it. And even with this mode off, I can actually click on these entities to select individual ones, or click on the root to select the root. You can also collapse them so you only see the root. And when you have the root selected, you can transform the entire thing as if it were a single entity. Each of these entities is actually, if we pick on a sub-entity here, let's look at the phonograph, you can see down here that it actually inherits all of its translation, rotation, and scale from other entities, or from the entities in the prefab. So I can take this and override these transforms for any particular object here. So notice now this has a unique translation. If I select the prefab root itself again, I can still move it around as if it were a single entity. I can also come in here and select this guy and reset his transforms to go back to whatever the prefab had. Now this has one advantage, one major advantage actually, which is I can now go back and modify this prefab file to change things slightly and have those changes reflected automatically in instances of that prefab. So to show this, I'm going to go ahead and save this out, make sure to save it outside of the palette directory since this is not intended to be a prefab itself, just a scene. And create test.gsa. Okay, that's good. Now we're going to come in here and load the prefab file itself. So let's come in here, palettes, test prefabs, table of stuff. Alright, now if I were to move this palette here, so I'm going to move this phonograph over to a different location and save this back out again. Now if I go back to the recent file that I just had, you'll notice that that file has got the phonograph in the new location, and that is the new inherited location. So this means that you can create prefabs and modify them after, including adding or deleting entities from them, and have those changes reflected automatically upon load when you load a scene that actually has instances of that prefab in use. Another way to create a prefab is, let's go ahead and create a new file here, is to create just some entities in it and select all of them and then say make prefab. So we're going to do that first here. Let's place a table, let's place books on it again, and Jacob's ladder on it. So now we're just going to select all of these entities, right click in the selection panel and say create prefab from selected entities, give that prefab a name, and it's going to prompt me, do I want to replace all of the entities in this scene with an instance of the new prefab? in many cases this is exactly what I want to do. So I'm going to click yes, and now notice I've got a prefab in my scene here called Table with Stuff 2, and it acts just like any other prefab. And I now have a new item in my prefabs palette. If I look over here, that's now Table with Stuff 2, so I can go in and instance additional copies of this throughout my scene. So that's the basic overview for prefabs. Prefabs, again, are just GSA files that get saved out in the palettes directory, so any GSA file in that palettes directory will be loaded as a prefab. You can instance those into the scene and modify them later and have those modifications inherited. That's pretty much it for this video. Hello, my name is Paul McLaurin, and in this video I'm going to talk about one of the new features that we've added to Scene Designer in Gamebryo 2.6, which is called tags. Tags are basically the ability to add a custom string to any template or entity in the scene and automatically provide some extra abilities to work with entities in the scene by sorting and searching for entities by tag and selecting entities by tag as well. So this is a version of MATLAB that ships with Gamebryo 2.6, and it's been modified to make a few changes. So first off, each of these categories of palettes, or of templates in the MATLAB palette, have been modified with tags. So we're going to just pop up the properties from one of these things here, and you see that this particular prop cans has been tagged with a string called prop. And we can also, go in here and add an additional tags. So let's add an additional tag called cans to it. And you can see here that now this thing has prop and cans on it. Now because this is a template, this means that any entity in the scene that actually derives from this template will also inherit the prop and cans properties. So for example, let's go ahead and select all entities in the scene with that. And let's choose just one of these entities and take a look at its properties, and we'll see down here that it inherits prop and cans. These are shown up with brackets here because these are inherited by the template, so they're inherited from the template itself. I could also come in here and edit this particular instance of prop cans to add some new tag, so I'll call it my special tag. And now you'll see that I'll have my special tag, which is not inherited, and I have prop and cans, which are inherited. Another thing I can do is I can select multiple things. So let's say I'll select this cemetery and this torture chamber room, and come up here and click the Add Tag to Selected Entities and add a new tag. And now you'll see that these select entities list that they have the added tag property in common. You can also select some entities and say remove tags, and this will show, since I have the same one selected, these are the tags that are on those two entities in the scene that can be removed. This will show the list of all tags on all the entities that you have selected, so you can remove any tag from all of those entities. You can also pop up edit common tags, and this will pop up an editor that will allow you to add, remove, or rename tags that are common between all the selected entities. So what does all this give you? You've now added tags, removed tags, you can edit tags. What does this do? Well, there's a tags manager in Scene Designer now that keeps track of all the tags and where they are, who is inheriting which tags from what templates. And it provides opportunity to do things like this, select by tag. So down here and I want to select all characters, or I want to select all lights, or maybe I want to select all rooms. And so you can see it just makes it's a very easy way to sort of do data-driven selection sets. So we've always had the ability to manually create a selection set and select a bunch of things that are supposed to be in that selection set. But now you can sort of have it automatically work. So if you have any things that are labeled as props, I can just go ahead and select them and it'll select all props. So you can see this working, maybe having NPC tag that tags your non-player characters, or a weapon tag that tags all of your weapons. So those can be set up in the palettes and inherited, or you can set things up individually on the entities in the scene. And so it just provides a really nice way of having a data-driven selection process in the tool. There's also a tags panel that's new. This lists all the tags that are known in the scene. I can right-click, or I can click on any tag and hide all of the entities that tag has, or unhide all of them. Let's do that with something that you'll be able to see. Let's say rooms. Hide all the rooms, unhide all the rooms. Occluders are another one that are currently unhidden. I'm going to hide those. So you can hide and freeze all of these. Now these work a little bit different than the layers do. When you hide and freeze layers, it's sort of metadata on top of things. So you could actually hide a layer and unhide a layer, and the originally hidden entities won't be unhidden. That is not the way tags work. Tags is more of a shortcut. This is exactly the same thing as saying select by tag, room, and then hiding them all. So it's just a shortcut for being able to do that. And of course all of these things are undoable as well. That's pretty much the overview of tags, the new tags feature in Scene Designer. Hello, my name is Paul McLaurin, and in this video I'm going to talk about one of the new features that we've added to Scene Designer in Gamebryo 2.6 called selection filtering. Selection filtering is a way to narrow down the number of entities that are displayed in the selection panel based on various criteria. So to show this off, we're going to go in here and activate the selection filter. There's a little button in the selection panel called Enable Selection Filter. Notice that this will change the border of the selection list to red to indicate that we are in a filtered mode. It also pops up the selection filter panel. Now this is a command panel like any other, and we're going to just dock it down here for simplicity right now. And notice that it says it's enabled. You can enable it and disable it from here. You can also disable the selection filter from this toolbar button right there. And when this is filtered, you can go in and filter by many criteria. So one of them is filtering by name, entity name, template name, or component name. So I can filter by name. I want only the things that have the name, cemetery in it. Notice it narrows down in real time. I can also do it by template name. So if I know the particular name of one of my templates, it'll only show me things that match that template. Or I can do it by component name. So if I have a particular component like a light component, this will narrow down to show me only the things that actually contain the component with that name. I can clear all those out to not narrow by name anymore. We can also filter by layers. So in this particular example, we've got multiple layers in the scene. I can say I only want to see things in the central hub. Or I can say I only want to see things in the central hub with the name prop. So these can all be stacked together. And you can have multiple selected as well. Central hubs and side room and default. If none of them are checked, then we're not filtering by layer. And you can filter by tags. So there might be all kinds of tags in here that that might have been added. You can filter by those. I only want to see the props, or I only want to see the effects. And so it just makes it very easy to turn filtering on and off to find what you're looking for based on the metadata, tags, layers, and then entity, template, and component name that's in the scene. That's our new selection filtering feature.
In this segment of our video series on terrain editing, we're going to talk about the UI and tools in Scene Designer used to edit and paint terrain. First, let's make sure our terrain command panel is visible. So first go to View Command Panels and select the Terrain Command Panel. So as you can see, I have docked the terrain panel on the right side here. And basically I want to go through some of the user interface elements of the terrain command panel. At the top, you can see that there are import and export buttons. These buttons allow you to import existing height maps or export your current height map for fine-tuning in Photoshop or some sort of other art package. Below that, you can see brush shape. In this release, we have support for a circle brush, and then you can adjust the inner and outer radius of that circle brush. Below there, you can see an empty list of brush elements. Brush elements are basically building blocks or operations that you can apply to your terrain as you paint, and each of these elements can be chained together. For example, if we click the Elevation Sculpt tool, you'll see that that brush element is there visible, and you can adjust its strength and its percentage of that strength to apply to the terrain as you paint. Next, we have a Flatten tool that allows you to just flatten areas of your terrain. We have a Blend or Smooth tool that allows you to go and fix up any sharp edges of your terrain and smooth those out. We have a Noise tool, which allows you to specify strength of noise and just applies random noise as you paint the terrain. This last tool is called Align Sculpt, and Align Sculpt is a little different from Flatten. It's very similar, but depending on where you click on the terrain, it might align to the bottom or the top of your click. As I said before, you can actually chain these operations together. So if I click Elevation, and I want to elevate my terrain, and I also want to apply noise to my terrain as I elevate, I can merely drag and drop my noise brush element to this list of brush elements. So now as I paint, you can see that the Elevation tool will get applied, as well as the Noise Sculpt tool. So I will have noisy, elevated terrain as I paint. And we'll get into that a little later. The other command panel that I want to look at is the Material Palette command panel. And so if we go to View Command Panels and select the Material Palette, we'll see that this will bring up a list of materials. Now I like to drag my material palette to the bottom here so I can see it a little better. And what the material palette does is it allows you to edit existing terrain materials and create new terrain materials. So if I right click an existing terrain material and do edit, we can see that this dialog box appears that allows you to specify the name, a package that you want your material to belong to, and specify different textures for your material. So textures that comprise, so a terrain material can have various different textures applied to it. It can have a base map with an optional detail map in the alpha channel of the base map, and it can have a normal map with an optional parallax map in the alpha channel of the normal map. And as you paint the terrain and assign textures to your material, the terrain will automatically update and respond to those changes. You can also tag materials, which show up down here on the left side, but we can tag materials with any human readable tags that we want to make it easier to search for them. You can also assign arbitrary metadata to a terrain material. And metadata is extremely application specific, and it's very generic, but it allows you to attach things such as speed, audio, or any string descriptions, integers, floats, etc. to a material that you then paint on the terrain. In the runtime, as a player or someone is walking across the terrain, you can use an API to query for metadata at that point. And of course, metadata is weighted based on the amount of material present at that location. In this video series, we're going to start talking about how to sculpt our terrain in Scene Designer. Before we begin, we must create a terrain. If you navigate to the General palette and the Terrain palette, you can see that there's a default terrain entity. If we double-click our default terrain and then left-click in our perspective viewport, we can create our terrain. I'm going to maximize our perspective viewport to make it a little easier to edit. So now you can see we have our terrain. Obviously it's very flat and not interesting, but I want to show you a couple things. First, go to Rendering Modes, Wireframe. You can see that our terrain sector, which is about 1 kilometer by 1 kilometer, with 1 meter spacing between vertices, is properly LOD'd. As I zoom in and out, you can see the LOD levels are changing. Now let's go ahead and start painting our terrain. Switch back to the standard rendering mode and go to our Terrain Editor command panel. Select the Sculpt element and add an Elevation Sculpt tool. I'm going to actually lower our percentage down a little bit and increase the size of our brush. And now we can start painting. As you can see, we're slowly elevating our terrain. I'm going to go and adjust our strength to be a little stronger. And create a little mountain. In case you're wondering, the reason the lighting updates after we finish a painting operation is to make the painting operation a little more efficient. What's actually going on is an MBT frame is being calculated every time we release the mouse, so therefore we can have proper normal maps on our terrain. So now we've created some mountains, I'm going to go and flatten portions of those mountains. So I'm going to click the Flatten Sculpt tool and go back to my terrain and start painting. And as you can see, I'm flattening various areas of our terrain. Notice I'm just clicking. Now that looks a little ugly. We can see artifacts from our triangles on the terrain. So I want to go and use the Blend or Smooth Sculpt tool to smooth those out. Now I'm going to drag and paint. I'm actually going to increase my inner radius and drag and paint over my terrain. As you can see, it's now becoming a little more smoother between those transition points. Now I'm just painting and dragging and painting. So I'm going to go back to the Elevation Sculpt tool, and I'm going to hold down Control and lower some of these larger mountains. So I have a flat little piece in the middle. I'm going to go back to my elevation. I'm going to raise a little bit on the outside. And go back to my Smooth tool and smooth out some of those peaks. Once we've done that, let's go ahead and save our progress. So go to Save, and save your world in some location that you deem necessary. Before we complete this segment of the tutorial, I want to go and add our Elevation Sculpt tool again. And I want to drag and drop our Noise Sculpt tool. Now I'm going to increase our size, or our strength of our noise, and I'm going to start painting on the terrain. And notice I'm elevating as well as applying noise, which actually becomes very handy if you want to paint elevation or paint noise and paint textures or apply multiple operations at the same time. Now note, this looks pretty ugly. Our noise is applied a little too strong. So what I want to do is I'm going to go back to our Smooth tool, and I'm going to increase our radius, zoom out, and I'm going to start clicking on our terrain and smooth that out a little bit. Sometimes it helps to just single click the Smooth tool on large portions of the terrain in order to just smooth it out in one step. So it looks like we've actually smoothed it a little too much. Scene Designer supports complete undo and redo for terrain editing. So let's go ahead and undo some of those smooth operations. And now I'm going to go back and smooth again, but this time I'm just going to click in a few spots. So now you can see we have a little bumpy terrain and we have a little valley in the middle. Later on we'll add some water into that valley. I would encourage you to play with the different tools and try making different things out of your terrain. That concludes this segment of the video series on terrain. we've gone over various different sculpting tools, and later in the next series we'll start talking about how to paint materials on the terrain. In this segment of the video series on terrain editing, we're going to go over how to paint materials on our terrain. First, you can see I've added a directional light to our scene. This is just going to highlight our materials a little better. Now, in order to start painting materials, we need to create a material package. Material packages are used to organize materials that are applied to your terrain. So let's first create a new package. I'm going to name my package My Terrain. Now I'm going to choose a location for my package. So now we have a new material package called My Terrain. We now need to add a new material to that package. So create a new material by using the New Material tool. This brings up a dialog that contains the various parameters you need to use to create a new material. Let's first name our material Sand. Note you can put in an optional description. And now let's go over to the Textures tab and choose a base map for our sand. We're going to use a base map that it comes with the terrain demo, which is a sample in the Gamebryo release. So let's browse to our installation folder for Gamebryo, the samples folder and the demos folder, and go to the terrain demo, data, and choose the Sand 2008 D.tga texture. Now you can see we have a thumbnail of our sand texture. Go ahead and hit apply, and you'll notice our new material was created. Now we need to go over to our terrain editor command panel and make sure that the paint material brush operation or brush element has been added to our list of brush elements. The paint material brush element can be found in your material tab. Make sure you choose your package that you want to use and choose the material, in this case sand, that we just created. Make sure you're in terrain interaction mode by clicking the terrain button. You should see your terrain brush on your terrain, and click anywhere on the terrain. Note, this has applied the sand to the entire terrain. This is because it was the first material that has been applied to the terrain. In order to make sure that the terrain is solid, we've applied the entire material across the terrain. Now it looks a little bad. Notice it's repeating quite heavily. So we want to adjust the repeatability of our material just a little bit. So right-click our sand material and go to Edit Material. Going back to the Textures tab, we can see this tiling scale. Let's go ahead and change that to 32 by 32. That looks a little better. Notice if I zoom really close, you can see the fact that there's a detail map applied to this terrain as well. The detail map was stored in the alpha channel of our base map and is automatically applied to the terrain if it exists. Next, we want to create another material. So either using the New Material button or right-clicking and doing New Material, we can create a new material. Let's name this Rock. Going back to the Textures tab and choosing Base Map, let's select our Rock 2008D.tga texture. Again, this texture is in the terrain demo in your Gamebryo installation. Again, hit apply, and we'll see that we have a rock material in our material palette. Go back to the paint material brush and select rock. We can now paint rock on our terrain. We also want to lower our radius a little bit. Now let's go on and start painting some rock on our mountains. Note your materials blend together. Unfortunately, it looks a little bad because again it was repeated. Our rock is repeated quite a bit. So let's go back and edit our rock material, remember in our Textures tab, and change that to 16 in both the X and Y or U and V direction. That looks a little better. You can see that better tell that there's rocks there instead of just a repeated pattern. As you'll notice, the rock does have a detail map as well, but the rock isn't very rocky. So to fix that, we're actually going to add a normal map to our rock material. So right-click and do Edit Material on your rock and go back to Textures. We're going to choose a normal map for our terrain, for our rock material. The normal map is rock 2008n.tga. Once we hit Apply, you'll notice that our rock becomes much more detailed and looks much rockier. Our normal map actually also has a parallax map applied to it as well. The height map for the parallax map is stored in the alpha channel. So notice when I apply our rock, we can see much more detail in our rock, as the parallax and normal map provide much more interesting lighting. Next, we're going to create one more material, and we're going to call it moss. Go to your Textures tab, and for base map, choose the moss 2008d.dds texture. In your paint material brush element, choose moss. And let's go and paint some moss. We can also apply a normal map and parallax map to our moss. Right-click and do Edit Material, go to your Textures tab, choose Normal Map, and select the Moss 2008N TGA texture. Notice again we have a lot more detail as the rocks in our little moss texture really seem to pop out of the terrain. If we change rendering modes to wireframe, you can see that the terrain geometry is really not that detailed, but our normal map and parallax map really add to that effect. So that concludes this segment of our video series on painting terrain materials. We've created a material package and added materials to that material package. We've also explored the different texture maps that you can apply to your terrain material, and we've painted several of those on the terrain. Note in this version of Gamebryo, there's actually a limitation such that you can only have 4 materials on your terrain. However, each material can have a base map, a normal map, a detail map, and a parallax map, which, as you can see, gives you lots of detail on your terrain surface. In this segment of our video series on editing terrain, we're going to talk about how to place water throughout our world. Water in the terrain engine is represented by a plane. Planes can be oriented horizontally, vertically, or any angle in between. Therefore, you can make effects like small basins of water, waterfalls, or little small lakes. So to get started, we're going to double-click our default water entity and click somewhere in the middle of our basin. Notice the water plane is created where we clicked. Now we want to actually translate our water plane up a little bit in order to get some water level in our terrain. Next, we want to switch to terrain interaction mode, so our water won't actually be selected and highlighted. In Scene Designer, if you select entities, you'll see that they become highlighted. However, on the water, it makes it look a little strange to have blue water blended with our selection highlight color. So to turn that off, we need to go back to the terrain tool. Note, our water is still selected even though it's not highlighted, so we can edit the properties and get feedback as they appear. First, we need to change the size of our water plane to fit within our little basin. So to do that, we're going to use the scale tool and scale our plane. As you can see, we've now scaled our water plane to fit within the area that we want the water to appear. Now we'll switch back to the terrain tool and edit some additional properties of the water. First, we need to edit the terrain entity property. The terrain entity property is used to associate the water plane with the terrain for blending and transparency effects. So clicking on the ellipses, we'll see we can browse to a terrain entity, select it, and press OK. Now you can see our water is pretty transparent. It doesn't look very good yet, but after we adjust some more properties, we'll achieve a much nicer looking effect. So next, we want to edit the normal map directory. As I said earlier, the water is animated using a series of animated normal maps. Normal maps are stored in a single directory and are named such that this file name mask matches with the mask or names of the list of files, which you'll see in a minute. So if we click the ellipses on the normal map directory, we need to browse and find our normal maps. In this case, we're going to go to the Gamebryo installation folder and use the normal maps in the terrain demo, Gamebryo sample. So we're in the samples directory under data, and we're going to choose water normal maps and click OK. Notice nothing happened yet. If we browse to that directory where we just chose the animated normal maps, you'll see that each frame in the animated normal map are numbered water underscore and then the number 1, 2, 3, 4, 5, 6, 7, etc. We need to set our file name mask to map to that naming convention. So to do that, we go and edit our file name mask, and we change this to water underscore and then the name of the frame or the number of the frame, and press enter. So as you can see, we now have some form of animated water, but it still doesn't look very good because we see through it way too strongly. So before we change the see-through or the opaqueness or the density of the water, let's go ahead and add an environment map. In this version of terrain, water is reflected through a static environment map. Again, in our terrain data folder, choose the reflection DDS texture. Now we can see our water looks a little bit better since we have some reflections on it. We have a bit of ripple from our animated normal maps. And we have a little bit of shoreline transparency. Next, we want to increase the resolution of our mask texture. Our mask texture is used to blend the shore or the edges of the water with our terrain. So let's change that to be 256 by 256. You'll now notice that the edges are a little bit crisper. Next, we want to adjust some additional properties of the water. First, we want the fall off of the water to be a little stronger, meaning that we want the water to be more opaque the deeper it goes. So let's change this value to 0.7. And as you can see, as the water gets towards the center of our basin, it becomes a little darker and less transparent. We also want to up the reflection factor. Currently, our environment map is producing minimal results in terms of how it's rendered. We want to adjust that strength. So let's change the reflection factor to 2. Now we've changed it back to 0.5. Let's try 0.8. That gives us a decent result. See, as I rotate, see that there's a little bit more shininess on the water. Next, we'll tweak our specular factor. Now we can see we're starting to get some water that looks pretty good. We have a nice smooth transition between the shore and the water. And we have some nice little waves on the water. Again, I would encourage you to tweak these different parameters. Our depth threshold, for example, we can modify. And the depth threshold works in conjunction with the fall off, such that the water around the shore is more transparent or more opaque. For instance, if we adjust this to 100, you'll see that again the water becomes a little more see-through. If we adjust it to 5, you can hardly see through the water at all, and we have just this little tiny border around the edges of our water where it meets the terrain. Let's change it back to 50. And that allows us to see a nice little shoreline and to see our rippling waves. So this concludes our series on placing water in the terrain. Again, we could place several of these water entities in various different parts of the terrain and maybe orienting them such that you can have a vertical waterfall or a body of water that goes down the slope of the terrain. During this segment of our terrain editing video series, I want to talk briefly about how to create your own terrain entity template. First, let's look at our default terrain that comes with Scene Designer. You can see that our default terrain is actually about 1 kilometer by 1 kilometer, assuming you're using meters as units, and it has a 1 meter spacing between vertices. Our default surface mask is 256, or actually 64. We've changed it to 256 in other tutorials. And you can see it has a default transformation. Now let's create a new one, and we'll place that in our scene. So let's create our new template by using the new template button, and we'll name it My Custom Terrain. Now we need to edit our template and add the appropriate components to our terrain template. First, we need a transformation component, since we want our terrain to have a location in our world. We need a terrain component, which provides base terrain properties and functionality, and we need to add a terrain sector component. Now note, in this version of Gamebryo, we only have one terrain sector, but the terrain sector component still serves a purpose as being a 0, 0 sector. Now once we click OK, we have the same properties we saw in our default terrain. For this entity template, I want to create a terrain that is about 1/2 kilometer by 1/2 kilometer, again assuming meters as our units. So let's change our number of subdivisions to 4. Note, that actually causes our sector size to go down to 1/2 kilometer. We can also adjust our block side length, which means we can adjust how big we want our blocks to be. In this case, we've made them 64 by 64 vertices. Note, this again increases our resulting sector size back to 1K by 1K. So let's lower it back down to 32. We also want to change our maximum elevation to 600 meters. Actually, no, let's make it 100 meters. The maximum elevation allows all painting operations to cap or to get cut off at our maximum elevation. So anything you do to the terrain, you'll never have it greater or less than your min and max elevation. As you can see, as I said before, our default surface mask size is 64. Let's change that to 256, the same way we changed our other one. The rest of these properties can stay as they are. So let's close our template editor. And we'll double click My Custom Terrain and create it in our world. Now if we look at the properties of our terrain, you can see that our terrain is in fact My Custom Terrain, and we have a number of block subdivisions to 4 with a resulting sector size of 513 by 513, or roughly half a kilometer by half a kilometer. Now I'm going to do some quick sculpting operations just to give us some noticeable terrain to work with. I'm just going to paint some crude little hills here. In fact, let's up the strength a little bit. And so this terrain is pretty ugly. And that's okay. We're just demonstrating a few things. So let's go back to our entity properties. And let's actually adjust the scale of our terrain. The scale of our terrain determines the distance between each vertice in the terrain. So let's switch to wireframe mode and zoom in. And again, remember our sector size is 513 by 513, or about half a kilometer by half a kilometer with 1 meter between each vertice. Let's adjust our scale to 4. And let's actually double click our terrain so we can zoom back out and see it. You may or may not have to do that yourself. So now if we zoom a little closer, the spacing between vertices is actually now 4 meters by 4 meters. As we can see, if we zoom out, the level of detail is taking a stronger effect. Again, because we're farther away. Because now we're actually taking our terrain is actually covering about 2 kilometers by 2 kilometers. Let's change back to our standard rendering mode and go back with the smooth tool and smooth some of these sharp peaks. And you can see all those artifacts that we had before from our painting are essentially gone with the smooth tool. This is a very nice tool to get smooth transitions between your terrain. Now let's change the scale one more time, and you'll notice here that the grid, once we change our terrain, you'll see it cover more of the grid. So let's adjust our scale to be 8. I can see our terrain is much larger. Our terrain is now roughly twice the size, but there are 8 meters between each terrain vertex. So if we zoom really close, you can see there's a lot of distance covered between each of these vertices. Note, however, that the terrain resolution itself is still pretty good. If I go up to one of my hills and zoom in really close, you can see that it's still pretty smooth. As I use my smooth tool, I can get it even better. So as you can see, we can use the distance between vertices to our advantage to get a much larger terrain. Again, this is roughly 8 kilometers by 8 kilometers. And we still have pretty high detail as we get close up to our terrain. And so that concludes this part of our series on terrain editing. Again, we've created a custom template and changed the size of the terrain from 1 kilometer by 1 kilometer to half a kilometer by half a kilometer. And we've also scaled our terrain to have about 8 meters in between each terrain vertex. And we've also observed that even with such a dramatic scale, the terrain is still quite smooth. Hi, and welcome back. In this part of our video series on terrain editing, we're going to talk about how to place props on the terrain. In this case, we're going to take a few little buildings and we're going to place them along the terrain. So before we get started, let's do some simple sculpting and flatten out a little bit of area here on this hill. We're also going to add another terrain material. So first I'm going to add a terrain material called cement. And I'm going to specify a base map from our standard textures that come with the terrain demo. Now going back to the terrain editor panel, I'm going to choose our flatten tool, and I'm also going to drag the paintbrush tool for painting materials. So I'm going to flatten out an area and paint our concrete texture at the same time. So I'm going to choose our cement texture. I'm going to go flatten portions of the terrain. I kind of messed up a little bit, so I need to go back and smooth that out. I also need to go back and put some more sand here, so that looks a little silly to have concrete up on that hill. So let's go back and use our material painting tool, choose our sand, and click a little sand here on our hill. That's a little bit better. Now to place some buildings, we're going to go and click the button called Add Art Assets as Templates. And basically this is a shortcut for creating a new entity template from an art asset or a Gamebryo NIF file. So click that button and then we're going to choose our building medium NIF file. Now let's double click our building medium NIF file and we'll place a building on our terrain. Notice we can't see our building, but we did add our building. Let's click the Move to Terrain button so our building snaps to the terrain. Now let's just adjust our building and place it on the terrain. Note, I accidentally selected the terrain when I moved. So again, make sure your building is selected. Let's move our building and place it where we want it to be. In fact, it might be easier to change to top view to do this. So let's go to our top view and change our rendering mode to standard. Let's go ahead and make that large. Now let's drag our building. Make a copy of our building. And let's place a couple buildings on our little concrete pad. Now let's change back to perspective. And look at our buildings that we placed on the terrain. Note, again, we can move buildings or move objects on the terrain where we need to place them. And if we want them to snap back to the terrain, we can click the button called Move to Terrain. In addition, you can also enable Snap to Surface. And what Snap to Surface will do is keep the building attached to the terrain as you move it around. Once Snap to Surface is enabled, you can also enable Align to Surface. And this will allow objects to align to the terrain as you move them around. So as you can see, as I drag along this slope, you can see the object matching the alignment or the normal of the terrain at that point. So let's go ahead and disable those two features and look at our buildings. And that's basically all there is to it. Object placement along the terrain is very straightforward and very seamless. Objects can move around the terrain and be attached and snapped to the terrain, and aligned to the terrain as well. In this segment of our video series, I want to show you how to launch your world or your terrain in a Gamebryo preview application called CNAP. Before we can launch our application in CNAP, we must first create a camera. CNAP looks for the first camera it finds in a world and sets the camera location in the application to be the camera created in the world. The easiest way to do this is to go to View, Create Camera from Viewport, and that'll create a camera from our current perspective viewport. You can also place cameras as you would any other entity. So now that my camera's been created, I want to change the name to be My Camera. And you'll notice that our viewport is now set to that camera. If we change back to our perspective viewport and we zoom out, you can see that a new camera entity has been created at the location that our perspective viewport previously was. So now that we have that, we can launch our world in Scene Designer, or excuse me, in CNAP. So if we go to View, Launch External Application, this will launch CNAP with our current world file. And there you go. We have our terrain in a running Gamebryo application. You can view our water. You can look at our buildings. And fly around our terrain. Note as we zoom far back, fogging is also enabled. Also notice that the terrain is actually geomorphed. As we fly to and from the terrain, you'll notice that even at the peaks of the terrain hills, very minimal artifacts are available. This is due to the fact that vertices are smoothly morphed between levels of detail. Pressing Escape, we can go back to Scene Designer and tweak our terrain and then run our CNAP previewer in order to see the changes. It's a very powerful way of quickly building a world and looking at it in a runtime Gamebryo application. So that concludes this segment of our video series, creating a camera and launching CNAP to preview our terrain.
Let's go over the environment variables and settings necessary for compiling with Gamebryo. Most of these things should be set up for you automatically during the various install processes, but if, say, a Microsoft library isn't properly registered with your operating system, you'll want to have some idea what's wrong and how to debug it. So if I use run cmd to bring up a command window, I can check environment variables easily. Set EGB lists all of the emergent Gamebryo environment variables. And here I can check that, yes, this has been correctly installed. EGB path is the route to the base of my Gamebryo installation. The shader library path and the tool plugin path point out particular paths inside that installation that will be referenced later. Here, everything seems to be correct. Now, to compile inside Visual Studio, lots of things need to be set up. One note is that Gamebryo only supports the full version of Visual Studio, not Visual Studio Express. I'll be looking at Visual Studio 2005 today. 2008 is much the same. In order to compile with Gamebryo, you'll need to have the March 2008 DirectX SDK and the March 2006 Microsoft Platform SDK. These should have their include and library paths set up in Visual Studio before the default Visual Studio include and library paths. So if I go to Tools, Options, VC++ Directories, and check Show Directories for Include Files, here the DirectX SDK and the Platform SDK are listed before any Visual Studio default directories. Similarly, if I check Library Files, the two Microsoft updates are included before any of the default older library directories that came with Visual Studio. If you don't have those files in there, you can get bad header versions or bad library versions, or just complete failure to link. Now, in order to get your code compiling with Gamebryo specifically, you need to tell Visual Studio where to set the include directories, where to set the link or directories, what libraries to link with. So for include directories, if we check the project's properties, you want to make sure that the configuration properties for C, C++ lists additional include directories of exactly what's here: EGB path, SDK, Win32, include. Remember that in the previous step, we used set EGB to check in the command window that EGB path was correctly set. This will go then to the root of our installation of Gamebryo and look for the include path. Similarly, we need to make sure Visual Studio knows which libraries to link with and where to find them. Second part first. In the same property page, the linker section has a general subsection which lets you specify additional library directories. Here, EGB path, SDK, Win32, lib, VC80 for Visual Studio 2005, and then a final directory based on what sort of build configuration you're using. We'll talk about the build configurations after we've gone through all the parameters. Which libraries to link with? The next subsection of this property page lets you list additional dependencies. What's necessary for every Gamebryo application is NISystem, NIFloodgate, NIMain, NIMesh, and a renderer, either NIDX9renderer.lib or NID3D10renderer.lib. Now, you may look at this list of libraries and say, no renderer is there. That's because NIAnimation uses pragma directives inside the C++ code to force linking with an appropriate renderer. You can do that too if you want. The rest of these are application-dependent libraries. Now, some of these things are not obviously set in every single Gamebryo application because Gamebryo also uses Visual Studio property sheets. If you go to the Solution Explorer in Visual Studio and click on the Property Manager tab, you can see which configurations exist for each project and what properties they're inheriting from standard Gamebryo property sheets. You can find these inside EGB path, inside the Gamebryo installation, in the build directory. Now, finally, what are those build configurations? Every Gamebryo application can be built several different ways. For instance, the standard material demo comes in debug, release, or shipping variants. The Gamebryo documentation has a Gamebryo build configurations page that lists the configurations for each hardware platform. So for PCs, we have debug, release, and shipping modes with both statically linked and dynamically linked libraries. Debug mode doesn't have any optimization and has full logging. Release mode has optimization turned on, but also has full logging. Finally, shipping mode has optimization and no logging at all. Gamebryo has a sophisticated rendering system, but you'll do most of your programming at a higher level. Emergent provides application frameworks as prototypes for complete applications. Here's a list of the Gamebryo application framework libraries and their dependencies. The two principal framework libraries are NI-application and NI-sample. As you can see, NI-sample is an extension of NI-application that takes advantage of some of the other utility libraries as well. If you look in the Gamebryo distribution on disk, you'll see NI-entity in there as well. That interfaces with the Scene Designer tool and is part of the entity-based approach to gameplay programming that we'll be talking about at length in this video tutorial series. So we'll deal with that in another segment. NI metrics output, off by itself at the bottom, mostly comes up when you're doing performance tuning, which we're not covering here. NI application is a basic platform-independent application wrapper. It handles all of the tasks necessary to start up a Gamebryo application. Whatever window creation your platform requires, setting up the renderer, setting up the input system so that you can read the keyboard or the mouse or the gamepad, processing command line arguments, tracking the frame rate, and providing a skeleton main loop. All of these are virtual functions that can be overridden as necessary or modified, and there are further hooks into the system for some commonly altered subsets of these functions. With all of this provided for you, a new Gamebryo application can be up and running very quickly. Give it a couple of models to load, tie the input system to moving a camera or moving a model, and you should have pixels on the screen. To get started with NI application, you'd probably go to override create scene. Create scene builds or loads objects into the scene graph that's going to be used. A trivial example is on screen right now. We create a stream to load data off of disk, give it the file name world.nif, passing it through a utility function that does whatever platform-independent work is necessary to turn that file name into a complete path, load that stream, and if the stream load is successful, assume that what we want to render is the first object in that stream. This is very, very simplistic. In many of the demos and full demos that ship with Gamebryo, you'll see more complicated work in create scene. For example, Metal Wars reaches into that stream that's loaded by the NIF and looks for specifically named objects and assigns different pointers to those, does different pre-processing on different objects in the NIF. This is one of those places where the programmers and the artists have to communicate so that the artists know how to label things in the NIF that the programmers are going to work with. You don't really have to worry about calling the base class version of create scene because it just builds an empty scene graph. NI application uses the NI input library to sample keyboard, mouse, and controller input every frame. You can override process input to respond to this data. You can read the documentation about NI input and its API if you want to do something fancy, But for simple applications, just do the sort of approach that you'll see in this sample code. Place some code that reads the input, checks to see if particular keys were pressed during the last frame. In the case of the example on the screen, if W is pressed, move forward. Hey, you're 3/4 of the way to your first-person shooter control scheme. Here, you do want to call the base class version. That will catch escape as a way of quitting your application. Okay, you might want to override that. And that will process visual tracker input. We'll talk about the visual tracker in a future segment. Update frame is NI application's core main loop. NI application update frame will call process input, calculates the application frame rate for that visual tracker, and doesn't do much else. If you have any animated objects in your scene graph, your application's update frame will want to update them to make sure their animations are appropriate for this new frame, and perhaps do some rendering work. NI sample is an extension of NI application that is used in all of the Gamebryo demos and tutorials. It builds some sophisticated navigation controllers that you can just grab to get normal camera flying, mouse look type interfaces, or camera orbiting object type interfaces, and puts words, checks boxes, sliders, other simple widgets on screen. For commercial projects, people often use Scaleform or Anarch. For academic projects, we've had many people having success with Crazy Eddie GUI package, which is open source and free. But here's the NI user interface example of most of our widgets. There's a UI manager class that provides standard components, and you can bring these up on screen. Since all of the samples use them, there's lots of code you can look at to see how this works. As you read Gamebryo code, it helps to know our standards. Naming conventions help you recognize the parts of the Gamebryo library and identify their roles. Class names use the NI prefix and camel case, so you'll see things like NI object or NI stream. Class scoped enumerations and static constants are capitalized with underscores for word separators, like stream OK, classic C style. We name variables in Gamebryo using a systems Hungarian notation. So every variable's name identifies its scope, its lifetime, and some facts about its type. Any class member variable starts with an M underscore. Any static class member variable starts with an MS underscore. So members are picked out immediately. Type is indicated by a prefix. The most common one is SP, smart pointer. And it's going to be very important that you're aware of the difference between SP, smart pointer to an object, and PK, regular C++ pointer to an object. We'll discuss that in just a couple slides. The Gamebryo hierarchy has a deep but narrow inheritance core with broad and shallow branches coming off of it. The scene graph is at the bottom, below the diagram that you see on the screen right now. And utility classes branch off the sides, depending on what section of the core Gamebryo features they require. So, everything in Gamebryo inherits from NIMem object. This memory object overrides the new and delete operators so that allocations and deallocations go through Gamebryo's memory manager. NIRef object, reference object, does reference counting and smart pointers. NIObject, the core of the object system, has runtime type identification, cloning, and streaming. NIObjectNet gives every object a name, allows any object to have extra user-defined data attached to it, and allows the data on that object to be time-controlled, to be animated. Finally, at the bottom of this core to the inheritance structure is NIAV object, audiovisual object, something that's going to be in the world, visible or audible. These things all have a position, a rotation, a scale, some bounds, all the other features you normally think of as belonging to objects in a scene graph. This section of the video tutorial is only about the top 4 levels of that hierarchy, the fundamental properties shared by most nodes in the Gamebryo scene graph. When you're looking at any new class that you're not familiar with, it's always worth checking. Where does this class come from? So, memory management goes through NIMem object. And when you start up Gamebryo with the NIinit call, you can specify which memory manager to use. And the normal Gamebryo memory manager, which is high performance, the Gamebryo debugging memory manager, which tracks every single allocation, or some memory manager that you write yourself. New and delete are not used in Gamebryo. Instead, we use NInew and NIdelete for Gamebryo objects, NIalloc, malloc, realloc, free for primitive types. This is another way of making sure that people are being conscientious about going through the Gamebryo memory management system. C++ requires some pointer management, and this can lead to lots of bugs. If you lose your objects, you end up losing your marbles trying to track down the bugs. So NIref object provides reference counting to try to help you avoid memory leaks. Every subclass of NIref object has a convenience type of NIpointer that automatically does reference counting. This only works on heap objects, so you can't declare Gamebryo objects on the stack. And you don't delete smart pointers. Instead, you set the smart pointer to point to 0, to refer to 0, and that tells the memory manager this particular reference to the object is no longer required. So NIpointer is a template class with overloaded operators, and every single one of the Gamebryo classes that inherits from NIref object has an NIpointer typedef in it. So if you have NInodes, there is an NInode pointer, NInode PTR typedef that will give you a reference counted smart pointer to an NInode. Similarly for NIAV object, for everything else in Gamebryo. When you're working with smart pointers, you have to hold in mind the difference between smart pointers and regular pointers. You cannot mix the two freely, and this is why we are very careful to have an SP prefix on every variable that holds a smart pointer, and a PK prefix on variables that hold regular pointers. Gamebryo defines a single inheritance tree below NI object. There's another independent inheritance tree with its own runtime type identification system for gameplay objects, but we'll talk about that more in the video segments on the entity system. We have our own RTTI because in the early days of the C++ standard, C++ RTTI was not at all cross-platform. Further, C++ runtime type identification handles multiple inheritance, and that causes a pretty significant performance penalty. By requiring that Gamebryo be single inheritance in all the classes that the renderer knows of, we can keep type identification fast. Is exact kind of is very, very fast, and is kind of and dynamic cast are relatively fast. So you can use RTTI in a game without destroying your frame rate. If you're building your own classes and you want to build into or buy into the Gamebryo runtime type identification system, there's an NI declare RTTI macro for your header, an NI implement RTTI macro for your C++ CPP file, and boom, you've got it. The fourth layer of the Gamebryo inheritance structure is NI-object-net. Net stands for names, extra data, time controllers. Every NI-object-net has a name, and a name is a fixed string. Fixed strings are stored in a shared common area of your application. Any particular string exists exactly once. So the word node would exist exactly once in that shared string area. This means that NI fixed strings can be compared very quickly with a pointer compare, but they are very slow to be built. So ideally you want your application to create NI fixed strings only when necessary. But comparisons can be done cheaply, which means we can traverse a scene graph quickly looking for a particularly named node. All of these named nodes can have arbitrary sorts of application-defined extra data. This could be boxed primitive types, integers, floats, boxed arrays of primitive types, or more complex types that make sense in a graphics application, colors, strings, text keys for animation timing, vectors. Now here's an interesting leak in our smart pointer model. These things are reference counted internally so that we get memory allocation correct and can track leaks, but they're not returned to the user via smart pointers. So you need to make sure you never call delete on a pointer that's returned to you when you ask Gamebryo for some extra data. Just like Java, all of the primitive types here are boxed. There's a class. So a float will have a NI float class that contains the floating point value. Why is there all this extra data? Well, it gives us serializability. This data is persistent. You can write out a scene graph and the data is stored along with it, which means you can create extra data in your art tools, export it into NIFs that are going to be read by your Gamebryo application, read it into your game at runtime, act on it at runtime. This is one of the primary ways that artists annotate their art in a way that the program can understand, and allows artists or designers to vary values without requiring a programmer changing the source code or recompiling. It gives us runtime type identification. It gives us an automatic tie into the shader system. So most of these NI-object-net values can be fed straight into shaders if you're doing shader programming. And finally, it gives us introspection. It gives us some way for the application to know the types of extra data it stores, which means that tools like Asset Viewer can intelligently display this extra data and intelligently let people modify it without any extra code on your part for your particular application's requirements. This application-specific data can be updated by time controllers. Usually, you'll have an artist working on animations. They'll bake out a KF or KFM file, and you'll have an NI actor manager that pulls in all the animations for this actor, whether that actor is an animated character or some effect in the world. But you can go in at a lower level and deal with individual transforms, individual morphs, individual custom shader attributes, and their controllers. This is another place where you have to be careful about memory management. Internally, these things are stored as smart pointers, but in order to make return values from calls fast, in order to preserve performance in inner rendering loops, this data is always returned as a regular pointer. So you need to never call delete on this data. Now is probably a good time to mention Gamebryo's container classes. Gamebryo does not use the standard template library. Over the years, we've had a number of customers with the rule of no STL in their programs, and we have had lots of problems in the past using STL on consoles. The portability just wasn't there. Although that's improving, we still have our own container libraries with all the standard containers you might expect: lists, arrays, maps, queues, and sets. If you look in the documentation under template classes, you can find a list of all of these types and information about the specific subtypes that are available to you, and when you would want to use which type for optimum performance in your program. The Gamebryo scene graph has its own particular conventions. First of all Gamebryo coordinate systems are right-handed. If your right thumb points along the x-axis and your right index finger points along the y-axis, then your right middle finger points along the z-axis. Whether y or z is up is uncertain. In fact, x could be up. Gamebryo doesn't care. Now, many runtime systems use y, but Scene Designer uses z up. This mismatch is in part from a historical mismatch between the way Maya and Max, the two art tools most often used with Gamebryo, conceive of up. If you have rotations expressed mathematically, matrix rotations are clockwise. Unfortunately, quaternion rotations are counterclockwise. If you have to convert between the two forms, which usually comes up only in low-level animation code, you have to manually keep track of that difference and remember to insert inversions where appropriate. Getting both correctness and performance from the scene graph usually requires carefully calling update. Now, update is a function on every node in the scene graph, which you have to call every time a transform changes or every time the scene graph structure changes. Well, when do transforms change? When you're animating something, when you're morphing something. Scene graph structure changes when things are added to the scene, removed from the scene, moved around in your conceptual model of the scene. Why do we have to call update? Because Gamebryo caches as much information as possible at the geometry, at the leaves of the scene graph. And so when internal information changes, all the cached values at the leaves may need to be updated. And the bounding volumes in the interior of the scene graph may also need to be updated. So, to get correctness, you would think you would have to call update often and early. But every time you call update, you're making a downward traversal of the scene graph to update the leaves, and an upward traversal of the scene graph to update the bounding volumes. This is expensive. So for performance, you want to update the scene graph late and rarely. Usually what we would advise is that people structure their scene graphs to take this into effect. If you have a large part of your scene graph that is static, keep it separate from the animated objects in your scene graph. Batch calls together. Make all of your animations, all of your transformations, all of your changes to scene graph structure, and then call update once over the section of the scene graph that's changed. So you only have to do a single traversal. These sorts of changes will significantly improve the performance of your Gamebryo application. For example, if you have an animated character and you have to change the angles of all of its joint transforms, don't call update until you're done with all of the changes to that character's pose. Now for a brief introduction to the Gamebryo entity system. The scene graph is composed of NIAV objects, which are all things that are relevant to the renderer. Now, render is important, but it's not the game. Entities are objects that are relevant to gameplay. Most entities contain scene graphs, whether this is one character, one object that's decorating your game, or an entire game level. But the gameplay logic usually thinks about entities rather than nodes in a scene graph. In the entity layer of Gamebryo, we support multiple inheritance through interfaces. So any entity is a thing with properties. It also has an error reporting interface and a command encapsulation interface. By bundling commands up as objects, we have strong support for undo and redo in all of the tools in the entity system. By bundling up error reporting as a separate side of an object, we can have uniform error reporting, essentially aspect-oriented programming, across the Gamebryo entity system. An entity is a thing with properties, and it can contain many components, each of which is a thing with properties. Entities or components support reference counting, but not through the Gamebryo NIREF object system, because this is a different inheritance hierarchy. Similarly, there's some RTTI support, but not the standard Gamebryo scene graph layer runtime type identification. So properties are individual pieces of data in gameplay objects. These all support reflection. You can write code that asks an entity or a component, what properties do you have? And because every property has additional information, tools can get at this additional information. Every property has a primitive type. Is this a float, an int, an array of floats, a string? A semantic type. What's this array of floats mean? Is it a position, or is it a normal, or is it a color? A display name, some human readable text. A description, which is also longer human readable text that a tool can display as a tooltip, etc. So every tool can automatically query an entity or a component, figure out how to build in code an editor for that entity or component without you having to write any specific code for that particular object. So an entity system can be used across any sort of game. You say, I need an entity, it has this component, and all of the tools that work with entities will instantly know how to display it, how to let you edit it, how to read it in, how to save it back out. Properties can also contain collections of values, and they can be shared between components. An entity is a flat collection of components. There's no hierarchy internal to an entity. Each component is a small bundle of properties. The difference between it and an entity is that components don't exist by themselves. They only exist as part of an entity. Typical components are a transformation, which in Gamebryo means a translation, a rotation, and a scale. A scene graph, the critical part of the data there is the path to a NIF on disk, which can be loaded to instantiate that scene graph. A light, a camera, a path to a KFM file, which, if loaded, gives you an animated actor with both geometry and animations. A path to a SPT file, which, if you have SpeedTree, can be loaded to give you a SpeedTree forest. A path to a terrain object, which will give you landforms in Gamebryo. An entity can have any subset of these or other components, including components that your game creates. Some of these components can depend on other ones. For instance, both the actor and the scene graph depend on a transformation. An entity that has a scene graph component must also have a transformation component. That way, the system as a whole knows where to place that entity scene graph in the world coordinate system. So for instance, if you had a single entity that held your level geometry, there would be some terrain, perhaps. There would be a forest, perhaps. Maybe some fixed cameras, some fixed lights, some static geometry in a scene graph, and a transformation. An entity that held a character would have a transformation, a scene graph for that character's geometry, and bones and skinning data, and an animated actor, the KFM that has all the character's animations and how those tie into the bones and the skinning. You can find plenty of examples of this in EGT path samples, models, scene designer examples. And all of those examples can be loaded into Scene App, our shell application that loads entity system data files.